to do this little worksheet here, and we're just going to run through it together, make sure everybody understands each part. So the first question was to fill out this little table I gave you. Oh, is it still? Oh, what on earth? Hang on, let me pause it. So we've got this paper here. And the first thing I had you do is fill out this table. What is an acute angle? What is a right angle? And what is an obtuse angle? So first of all, how do we define an acute angle? That's the right angle. Yes, an angle that is less than 90 degrees. So I'll say an angle less 90 degrees. Perfect. So for the angle that you drew in your little guide, or if you haven't done it, go ahead and copy what I'm doing here. We always start with a ray on the bottom. Create a little point that's going to become our vertex. And as long as your angle is not going straight up and down or further like this, you could have picked anything within this smaller range. So I'm just going to put kind of a random line here, like this. So we have described the angle. We drew the angle. How would we label this? You guys remember what we do after we draw the angle? Yeah, we're gonna do that partial circle or that arc, and then we would get the measure of it using our protractor. And I probably need to extend my edges, but for this case, since it's a guide, we're not gonna be as exact. It's just a little practice problem. I'm gonna line it up with my ruler, see if I can get close to the answer. Make sure I got this out. Okay. My angle that I drew looks to be about 36 degrees, is what I would guess. So whenever we label how many degrees an angle is, we would just write the degrees next to the arc. Okay. Any questions about this part of our worksheet? You guys got that? Okay, let's do a right angle next. How do we describe a right angle? Yeah, it's an angle that is exactly 90 degrees. So I'm going to say an angle exactly 90 degrees. All right. So same thing, we're going to draw it. Start with a straight ray going across the bottom. And for a 90-degree angle, we'll be going perfectly up and down. And this might not be as precise as whenever I'm asking you for a grade. So let me just line this up. Make sure it's hitting the 0. Let's see. That's about good. And let's to go through 90. Here. 90-degree angle. Okay. How do we label a right angle? Yes. Put a square inside, just like that. And we could write 90 degrees, but we actually don't have to in this case. If we have a square, that's going to tell us it's 90 every time. Do we have any questions about the right angle? Okay. Is everybody caught up? Does anyone need time to write this? Okay. Let's move on to an obtuse angle. How do we describe that? Yes, it's going to be an angle larger or bigger than 90 degrees. Larger than 90 degrees. Okay, so same thing. We'll start with our ray on the bottom. And this time I'm going to make it a little shorter so that I can fit that outward angle in my box. And let's do, as long as it's opening wider than straight up and down, you could pick any other angle. So I'm going to just put it there and see if I can guess about what that measure is. Not going to be perfect, but it's probably about, here's 130, 31, 32, 33. I'm going to go with 133 degrees. So same thing, we'll draw that arc around the vertex. And then we'll write the number of degrees that we got. Mine was about 133. Okay. Do you have any questions about those three types of angles? Or you guys feel okay about that? Okay, I see some head nods. I'll say that means you probably feel okay. So let's go ahead on to the second part. This is where it gets a little trickier. We're doing constructions here. So we are constructing with our compass. So this is a compass. And if you missed yesterday, this would be a really great time to pay super close attention. Whenever we want to create a perpendicular bisector, first of all, what does perpendicular mean? You guys remember that? It's going to go straight up and down at what angle? What's the measure of an angle that goes straight up and down? 180 would be straight across 90. Yes. So whenever we have a perpendicular line, every intersection is going to have a 90-degree angle in there. So instead of using our protractor to do that, we can use our compass. And here's how. First thing we want to do is take the compass and put the point, it's very sharp, on one of the end points of our line segment. And we want to open our compass up. And yesterday I had you open it all the way to the length of the line segment. But we actually, to save space, we can do it slightly smaller as long as it's bigger than half of the line segment. If we make it too small like this, we're not going to create the intersections we need to create. So we're going to make it at least half the size. So I'll go about here. That's more than half. And we're going to create our first arc somewhere in there, just like that. Once you've done that, we're going to do the other side just by switching our compass around. Now, the most important thing here is that you keep your compass open at the exact same angle the whole time. If you let it shift and get bigger or smaller, your bisector is not going to be perfect. It's going to be a little off. So here we are on the other endpoint, and we are just going to mark there where we now have an intersection on top. Let you guys get to that point. Now, once we've created this intersection on top of our line segment, we want to make one on the bottom too. So put it right back on the endpoint that we started with and create one underneath like that. And then you're going to do the exact same thing on the other endpoint. We're just creating 4 little arcs and 2 intersections. So you just need those to cross. Let everybody get to that point. Okay, now we are done with the compass. We have 2 points of intersection here. So now we just need to take a straight edge. So we can use a ruler or the edge of our protractor. And we want to just line up with those intersections we made. And if we were precise enough, we were careful enough and did it correctly, we should come up with a line that perfectly cuts our original line in half. So how do we show that these two parts of my line segment are the same length? How do we do that? Yeah, we're going to use two little dashes like this. 1, 2, 1, 2. This is going to show that our lines are split in half perfectly. And then how do we indicate that we have a 90-degree angle? Put the box in there, put the square. So we're going to do it just like this. So this is what your final product should look like. Yeah.
I heard the same thing, so I did the whole line. Would it be wrong?
Nope, that would not be wrong because he's perfectly right.
It's still crossing sections.
Yes, exactly. So I'll show you this. If I were to do it by doing the whole length of my line segment, I still should get this line intersecting at about the exact same spot. So I'll show that too. Oh my goodness. Difficult. And the other side. It might not be perfect because I got a shaky hand, but it looks like it's gonna line up pretty darn close. Right about the same. So you could do it either way. You could do it from endpoint to endpoint, or you could make it a little smaller to save space on your paper. Just make sure that you don't make it less than half. So here's what would happen if I did it too small. I'm going to come up with an arc here and an arc here. And see how they don't touch? That's not going to help me find my bisector at all. If they're not touching each other, they're not giving me somewhere to cross through. So we just need to make sure that it's open wide enough to create an intersection. Gives us a guide to know where to draw that line. All right, do we have any questions about the perpendicular bisector? Any at all? Okay, if not, then we're ready to move on to our angle bisector. This one we didn't spend as much time on yesterday. This one's a little bit trickier. So, you'll see on your guide sheets that I gave you, we have a starting point of what? Where should I put the point of my compass on first? The vertex, very good. Just like the vertex is the starting point for a ray and for the angle, it's also going to be the starting point for our construction. So we want to open up our compass, and this time we want to make our arc not too big. If I were to make it super large like this, my intersection that I'm going to eventually create is going to go way off the page. It's not going to work. We want to make this one pretty small. So probably closer to a little less than half of this length. Again, it doesn't matter what opening you do exactly. It just matters that you're consistent. So I'm going to go ahead and start by making a little arc right there. And once I've got that first arc, once you all have that, look up so I know you're ready for the next step. And perfect. All right, so step 2 is you're going to use either this intersection you created or this intersection. Doesn't matter which one you do first, as long as you do them with your compass opened at the exact same length. So I'm going to start here at the bottom. You could start at the top. And what I'm going to do now is create an arc somewhere inside my angle like this. And then you're just going to do the exact same thing on the other line, on the other ray of your angle, where you created that first intersection right here. And you're gonna see that you'll get a brand new intersection right in the middle of your angle. And once you've got that, you just take a straight edge and you connect the dots. Like this. There we go. Just like that. And to show that two angles are the same measure, we are going to draw little arcs inside of them. I'm going to put 2 lines on this arc, and I'll put 2 lines here. This is going to tell me that these 2 angles have the same measurement. So little arcs inside are going to tell me that they are the same. So if I need you to do this, I will tell you that I want you to do that. But right now, this is the first time I'm telling you to do it. So if you didn't do that yet, you didn't do it wrong. I just didn't tell you. All right. Do we have any questions about this process, or would anybody like to run through it again?
I don't know, I might have to do it.
Let's do it a couple more times because we didn't do this much yesterday anyway. So we're going to practice a little bit today. So that's the end of you do now. Let's flip this page over and we're going to use the back side. And let's practice some of these constructions. So let's actually practice with an obtuse angle because those I've found some people struggle with a little bit. So I would like you to make the first line of your angle or the first ray. We're going to start right at 0 and go all the way to right about 3 inches. Like this. We're going to create our vertex. After you've made your ray, let's get our protractors and let's make an angle so that we all have the same one. So we're going to line it up real good on there. And how about we do, let's do 140 degrees. So whenever I'm creating my second ray on this angle, am I looking at the numbers on the inside or the outside? Inside. Yes, because if we're starting from here and opening this way, we'll see that the numbers increase on the inside. They start from 0, go all the way up to 180. So let's do, did I say 130 degrees or 140? 140. Okay, let's do a 140 degree angle. I'm just going to mark that on my protractor like that. And then I'll remove it and connect those little dashes I made. So once you've made your 140 degree angle, it should look really similar to mine. And let's make a guide today. I'm going to make a little bit of an easier to read cheat sheet because I think the ones that I gave you, they're good to peek at. But even whenever I was reading through the steps I just found those online. They didn't make a whole lot of sense to me. I had to like sit and think about it when I was looking at them. So let's create our own step-by-step guides today. So how about we title this? Get something here. We're going to say Angle Bisector Guide. That way you'll have this, or whenever we do quiz, and you'll be able to look back at it and remember how to do it. Angle Bisector Guide. I'm gonna write out some steps. So, step 1. Shift this paper down a little so you guys can read the steps. Or does anybody still need to see that title? Put on. Okay, so step 1. Place the point of the compass on the angle's vertex. So that is looking like this. We're putting our point on the vertex, just like that. Okay. We also want to specify to make sure your compass is not opened up too big. So whenever I say not too big, you want it to be less than half of the length of those rays. So we can put that in parentheses down here. Compass opening should be less than 1/2 full side. So this side of it. Once we've got that written down, let's create our first arc. I'll wait till everybody's ready. Just look up to show me that you've written all this and you're ready to go. Perfect. Okay. So take your oh my gosh, not protractor. Take your compass and put that point on the vertex, and we're going to create our first arc right here. And sometimes I find it's easier to turn your paper than turn your compass, just like that. Because whenever I turn my compass, I end up accidentally changing how far apart it is. It's just a little bit awkward to use if you're not used to it. Okay. So does everybody have their first arc made? Okay, that's okay. Take your time.
How much is open as long as it's less than half?
Yes, as long as it's less than half of the length, it doesn't matter how big it's open. Just don't want it to be too big. I'm also gonna label this as my vertex. Kind of color, but this is, you know. Now, once you do have that arc drawn, I want you to notice that we have created 2 intersections on either side of our angle. We've got one right here, so let's mark that. And we've got another one right over here. We're going to be using those intersections for our step 2. Or we could say step 2 and 3. So I'm going to say step 2. These are both step 2. So let's write out a second step. So for step 2, now we want to keep about the same distance open. And if you lose that distance, you can always, like, let's say I accidentally open it way up. This is going to mess me up a little. We can then go back and just measure the distance again, put it back to where it should be. So you're going to keep that distance. And now your next point is those intersections we just created. That's where the point of your compass goes for step 2. So let's write that. Step 2 is to place the point of the compass on the intersections we made in step 1. Create 2 new arcs. In parentheses down here, I'm going to say the compass opening should be the same as step 1. So we want to keep it the same opening the whole time. Same thing, just look up at me whenever you're done writing step 2, and I'll show you how to do it again.
Does it say areas?
Where?
Right next to you.
This? So, sorry, my handwriting. Create 2 new arcs. So this is arcs. So when I say arc, I'm talking about like this circular thing that my compass is making. Okay, so let's do step 2. Take your compass, make sure it's that same length by lining it up. Mine actually could be open just a little bit more. Okay. And then here's where you want to place your arcs. They need to be inside your angle like this. So one about here. And another one here. And make sure that you're drawing your arcs long enough that they do actually intersect. Like if I were to only draw an arc over here and over here, not close to the middle, I'm not going to create a new intersection. I want to make sure that they're making a little X in the middle. So once you've done step 2 and you've made 2 new arcs, we're going to label that new intersection you just created. I call this step 3. Okay, so step 3 here. All we do is take a straight edge connect your vertex to that last intersection we made. Like this. And now we have two equal angles on either side. So if you're wanting to keep it as kind of labeled, I'm going to write out step 3. So step 3. So using a straight edge, a line from the vertex to the intersection created in step 2. That. And last but not least, we're just labeling. So we're going to draw those little arcs on either side of that angle bisector we just created. Just like this. And that just tells us that these angles are the same measure. Let me move this. Let's see those words. Okay. So here's our guide. We'll do a little more practice with that later on. But we are also going to introduce some new stuff today. Does anybody still need this? Are we still writing? Is everybody done? Awesome. Okay, so let's move on to our next thing. I have some notes for you today. And I put them to the side and I don't know where I put them. Hang on. Pauses. Today we are going to talk about a couple of different types of angles. And what I'm going to have you do is get out a fresh sheet and I'm going to have you write what I write. So at the top of our page, let's say other types of angles. Uh-huh. Oh, sorry, I didn't see your hand. Go ahead. Yes, we did, and those notes are all going to be on the video of the lesson.
Yeah. If I should skip a couple pages or not.
Even if you were to do it on the same page, let's see, I think we took, what was it? Was it 1 page of notes, maybe 2?
Yeah, because we have to draw some stuff, so.
Yeah. Just 1 or 2 pages if you're wanting to skip pages on your notebook. Okay, so other types of angles. So the first thing that we are going to write is adjacent angles. And that is A, D, J, A, C, E, N, T. Adjacent angles. So adjacent angles are angles that share a side and a vertex And they don't overlap. So I'm going to put that in parentheses. They don't overlap. So we'll draw a picture to explain. So, for example, if I were to draw angle here, I'm just going to put a random line somewhere in the middle. We'll call this angle A. We'll call this other angle right here angle B. So notice how I put one arc on A and two arcs on B. I put a different number of arcs to show that they're not the same measure. We only put the same number of arcs, just like we did when we did the bisector for angles. We would do two arcs on both to show that they're the same measure. We do different numbers to show that they are not the same. So these, angle A and angle B, angle A and angle B are adjacent angles because they're sharing this side right here, and they're sharing a vertex. They're connected. So that's just how we name those. Spell it wrong. A, T, J, A, C, E, N, T. They are adjacent. Sorry, guys. I need to work on my penmanship. Writing a little neater for you. We're going to talk about two different types of adjacent angles. So the first type, we're going to start with a straight angle. Do you guys remember what a straight angle is? We mentioned it just really briefly. Looks like this. You guys know how many degrees is in a straight angle? I'll show you. 180. Yes, very good. So a straight angle is 180 degrees. So I will label this one as 180 degrees. Also write straight. Right? And we are now going to put another ray somewhere inside of our straight angle so that we can make two adjacent angles within this. Just like that. Now I am going to put two arcs over here. Call this angle A. And just one arc over here. Call it angle B. So angle B refers to the larger one on my page. A is referring to the smaller one on my page. And what we can see by looking at this straight angle and knowing that it is 180 degrees total, you know that angle A plus angle B equals how many degrees when I put them together? What do you think?
180.
180. Perfect. 180 degrees. So this type of angle where we have a straight angle and then it's separated into two adjacent angles within that 180 degrees, we call this, I'm going to use the same color here, supplementary angles. That's Supplementary. Supplementary angles. Define it, say angles that add up to 180 degrees. So anytime we've got a straight angle and a ray coming out to separate them, we have supplementary angles. We know that those two angles added together are going to give us 180 degrees. I'll give you guys a minute to get that all written down before we move on to the last kind we're going to talk about today. Last but not least, on the bottom of your page, if you still have room, if not, you can start a new page. We're going to construct a 90-degree angle. Okay, what is a 90-degree angle called? A right angle. Perfect. Some protractor. Triangle. It doesn't matter. If you do it the other way, that's perfectly fine, as long as it's 90 degrees.
Protractor on my page.
That's okay.
Fine.
All good. It'll work regardless. And then we want to label this with that box. Bottom of that angle. Now, once you've got your 90-degree angle, we want to draw a ray coming out from the inside of that vertex here, somewhere in the middle, to create two adjacent angles. Separate this from. Once you've got your two angles, your adjacent angles inside your right angle, we want to label them as A and B. Or if you don't want to mix it up with the one above, how about we do C and D? Got C and D. We're going to write a similar statement as we did above. Angle C plus angle D equals what? 90 degrees. Very good. So angle C plus angle D equals 90 degrees. And these are called complementary angles. Different name. COMPLE. Complementary angles. The exact same definition as above, but 90 instead of 180. So it's angles that add up to 90 degrees. Yeah, for you guys to show me that you're done with these notes. By looking at that me just for a second. I know. Perfect. Perfect. For them, we're gonna do one more thing before we go. All done? Okay, awesome. So let me give you an example of where we would see something like this. Let's say, and now when we're drawing this one, we don't have to make it exact. We're just going quick. Let's say I have this here. Just get the rough estimate. Say this is 40 degrees. And this is X. How could you figure out what X is? Any ideas?
You have to use one of these. From the point all the way.
Say that again?
Use one of these. It's not from the point going around.
You could use a compass. You could use a protractor. What if we don't have a compass or a protractor?
Oh, yeah.
Smart. Yes. So guys, remember we actually created a little equation here. A plus B equals 180. This angle plus this angle is 180. We've got supplementary angles here. So I know X plus 40 is 180. So let's write that. X plus 40 is 180. How would we solve for X here? You guys messed with equations before?
Move the D over to the other side because X needs to be on the side by itself.
Exactly. We want to get X by itself to find that answer. So we do the opposite. It says plus 40 here. So we'll do minus 40 to both sides. Draw a line. My 40s cancel out. Bring down my X. Bring down my equals. And 180 minus 40 is what? 140. And that would be your answer. Now we know X is 140 degrees. It's kind of cool how we can do that. Kind of cool. Let's do a complementary one. So again, doesn't have to be exact. Yeah, mine's really not exact. Put a little box in there so you know it's 90 degrees. And say we have a 30-degree angle. And I want to know what X is. How could I figure out what x is here? 90 degrees minus the 30, exactly. So let's set this up as an equation. I know that 30 degrees plus x is 90 because it tells me here that there is a box. This is 90 degrees total. So x plus 30 equals 90. And same process. We'll subtract 30 from both sides. And I get x equals what?
60.
60. Good job. 60 degrees. Perfect. Okay, guys. We've got about 2 minutes left. I'll let you keep writing. I'm going to give you a short exit ticket today. Remember, if you don't have time to finish before you go, they're not due for a whole week. So you've got plenty of time. Anybody still need this? Do what? That's not today's exit ticket. Did you finish that one though? Okay, you're good on the back. We can hold on to that for now. I'm gonna have you do something different today. Let me grab a separate sheet of paper. Can I move this to the side, guys? Okay. So please title your exit ticket as Day 4 exit ticket. Please put your name on it so I can give you a grade. So right here, I've got a 90-degree angle. And got two adjacent angles. This one up here is 20 degrees. And I want to know how many degrees is angle X. And that is it for today.
You guys sign up there?
Yep, you sure do. So exit tickets will go up here at the front. You are welcome to try and finish it real quick. It is 10:25, so our class is over. If you don't finish, you're welcome to take it with you and bring it back Monday, Tuesday, Wednesday, Thursday. Next Thursday is the last day I can accept it. Okay, I'm gonna end that here.